friends, welcome to Gokul Global University. I am here to discuss one of the most important topic of organic chemistry, and that is an oxidation reactions. This topic is very much useful for the students of MSc semester 2. So let's start with the overview of this presentation. Introduction: Auto oxidation reactions. Osmium tetroxide OSO4, an oxidizing agent. Peroxy reagents, Baeyer-Villiger oxidation reactions, and the last one is Jone's oxidation reactions. So first of all, what is oxidation process? The very basic understanding of oxidation is an addition of oxygen and a removal of hydrogen. This process is a oxidation process. Oxidation process is a loss of electrons or increases the oxidation state of an atom or ion or a certain atom in a molecule. For example, methane to methanol. This process is oxidation process. Now, what are oxidizing agents? So, the oxidizing agents are a substance that has the ability to oxidize the other substance, and in other way we can say that to accept their electrons. Oxygen, ozone, peroxy reagents, these all are commonly used oxidizing agents. Many oxidizing agents like OSO4, osmium tetroxide, O3, O2, KMnO4, selenium dioxide, it's SeO2, some peroxy reagents, LTA, it's lead tetraacetate, then HiO4, MnO2, CrO3, then DMSO, it's a dimethyl sulfoxide, NBS, it's N-bromosuccinamide, K3FeCN6, DDQ, etc. These all are very good oxidizing agents. Here we discuss some of that oxidizing agents with details. So let's start with the first, auto oxidation reactions. So automatically happening reactions is known as auto oxidation reactions. This reaction is light assisted reactions. For example, alkane to peroxides. Paint gets spoiled after some times just because of oxidation process in presence of atmospheric oxygen and sunlight. It will trigger the radical formation. Polymers start getting decomposed in presence of the atmospheric oxygen and sunlight. The oils also oxidize in the presence of oxygen and sunlight. All these are auto oxidation reactions and we can't control them. Many reagents are stored in an amber colored bottle just to prevent the auto oxidation reactions. So this is all about auto oxidation reactions. Now we study the second oxidizing agent, and that is an osmium tetroxide. Here the osmium is attached with 4 oxygen atom with double bonds. It is used in transformation of alkene to 1,2-diols. Solvents can be acetone, tertiary butanol, THF, it's a tetrahydrofuran, ether, etc. Let's get furthermore information about osmium. So osmium and osmium reagents are poisonous and toxic, so careful when worked with osmium compounds. The second thing is osmium permissible limit is less than ppb, so it removed completely from the product after oxidation reaction. Column chromatography is used to remove osmium from product after reaction. Osmium is also dangerous because it can damage our respiratory tract and eyes as well. So let's go for the mechanism. Here the reduction of osmium is going to take place and the formation of 5-membered ring occurs. The 5-membered ring is very big because of 2 oxygen, 1 osmium and 2 carbons, and these all are in a same plane, so it does not twisted. During mild acidic workup we will get the diols. Product always formed at a less sterically hindered side. If there are 2 sides in alkane, one which is sterically accessible is favored always. If there are 2 double bonds in the starting material, one is electron rich and the second one is electron deficient, then the double bond which is electron rich is capacity will react the higher efficiency with osmium tetroxide. So this is about osmium tetroxide. Now we learn what is peroxy reagent. Peroxy means per oxy. This reagent is having an additional oxygen, that's why they called as peroxy reagents. The peroxy linkage is very much unstable and decomposed easily. Breaking of peroxy bond is a natural process, so that's why hydrogen peroxide H2O2 can be preserved in a dark colored bottle to prevent the further reactions. TBHP, it's a tertiary butyl hydroperoxide and cumin hydroperoxide, mainly used for epoxidation process of alkene to epoxide. Peracetic acid and MCPBA, it's metachloroperbenzoic acid, are also a good reagent for oxidation reactions. Major application of peroxy acid is to oxidation of carbon-carbon double bonds to epoxides. Now you have to question that what is epoxide. So epoxide is nothing but three-membered cyclic ring which is having one oxygen and two carbons. Peracids also known to convert ketone to esters, and the well-known example of this is the Baeyer-Villiger oxidation process. So we go for the mechanism. Here you can see the given ketone is oxidized to give ester as a product. First step is the carbonyl oxygen is attack on the hydrogen, and now the oxygen of peroxy reagent having negatively charged and the oxygen of carbonyl is having positively charged. Now negatively charged oxygen is attached with the carbon of keto group and give the structure which you can see in this slide. Now the oxygen is having two lone pair of electrons. These electrons attack on carbons, so carbon is having a pentavalency which is very much unstable in nature, and that's why the R1 which is attached with the carbon atom is migrates to the oxygen atom and we get the ester as a product. Benzylic and allylic having the highest migratory aptitude for this Baeyer-Villiger oxidation reactions. Here the migratory aptitude order is given in this slide. So basically the Baeyer-Villiger oxidation reaction is nothing but the insertion process of oxygen between the carbonyl and the two adjacent atoms. So this is about Baeyer-Villiger oxidation reaction. Now we have to learn the last oxidizing agent of this presentation, and that is Jone's oxidation reaction. This reaction is an organic reaction for the oxidation of primary and secondary alcohols to convert carboxylic acid and ketones respectively. The founder of this reaction is Sir Edward Jone. So this reaction is known as Jone's oxidation reaction. Chromium trioxide and sulfuric acid dissolved in a mixture of acetone plus water is known as Jone's reagents. So we will get acid when we do the we use the Jone's oxidation reagent having starting material primary alcohol, and the secondary alcohol will convert into ketone as a product. Now we go for the mechanism. If we take primary alcohol, we get acid as a product. First step is the oxygen is having two lone pair of electrons which attack on the chromium, and one of the oxygen is getting negatively charged, so it abstracts the H plus from the solvent. Now the H of the starting material, the hydrogen of the starting material, here we taken primary alcohol is abstracted and the formation of carbon oxygen double bond is occurs. Now the trivalent oxygen will break the oxygen chromium bond and we get aldehyde which is react with the water molecule and become a geminal diol, and this further oxidize and we will get acid as a product. And same as a primary alcohol, the secondary alcohol is also react with the Jone oxidizing reagent and form a ketone as a product, as you can see in this given slide. So this is the end of this presentation. The further reagents we will discuss in the next part. Thank you for watching.